All right. You guys ready? Are you ready? Are you ready? Are you ready? All right. Class.
Yes.
Ah, you're not ready. We're ready. Anyway, so you guys should be super excited because it's the last set of notes for this year.
You mean semester?
No, this year.
Oh, okay.
You know, 2020 is finally over.
Oh.
So this is just like, you know, this is 2020 version 2. So, anyway, all right, so graph secant, cosecant. So this is actually going to be like super easy if you paid attention for the sine and cosine. That's all it is. It's just your graph is going to look funny. And blah, blah, blah. Okay, this is on your reference sheet, just so you know. You need to know that. So this is what it looks like. Because this is secant, it is inverse or the reciprocal of sine, or I'm sorry, secant's cosine. So the cosine wave would actually look like this. So that would be what the cosine wave is. It's just when you draw your cosine wave, right here for this whole thing, you do it as if it's cosine, but at the peak, so the maximum, it flips up. At the minimum, the bottom part, it flips down. And everywhere that it would be crossing the x-axis is going to be asymptotes. Because if you look at it from here to here, this is going up to infinity, but all of a sudden down here, as we continue, it jumps, and now it's down here. It's down to negative infinity here. So there is an asymptote in between separating as this goes up to negative infinity, and this one right here goes down to negative infinity. Up to positive infinity, down to negative infinity. Okay, hopefully that might make sense. All right, so there's an error there. Okay. Cosecant, same thing. Cosecant is the reciprocal of sine. So this is technically going to be a sine wave. It's going to look like that. And we just, when we graph it, it just flips it upside down. Again, this one period is pi. It's 2 pi, but don't worry about that. Because it's the same thing as what sine and cosine is. Blah, blah, blah. Okay, so like I said, so cosecant goes with sine. Secant goes with cosine. So whenever you see those on a graph, you treat it as if it's either going to be a sine or cosine. And at the end, when it's time to actually sketch the graph, is going to be the difference. All right. 2 secant 1/2 x. So I'm going to pretend that this is going to be a 2 cosine of 1/2 x. Amplitude. Say it. 2. Right? It's 2. Period. Period for sine and cosine was always what? 2 pi. It's always 2 pi. Okay, it's 2 pi over b. Very good. 2 pi over b. So these ones are 2 pi over b. So the period is, and in this case, my b value is 1/2. 1/2. B value is 1/2. So it's going to be 2 pi over 1/2. But I have a fraction over fraction. I don't like fraction over fraction, right? I have to multiply by reciprocal. So that's going to turn into 2 pi over 1 times the reciprocal of the 1/2, which is 2 over 1. which gives me a grand total of 4 pi. Are you guys just not into it today? Is that what it is?
No.
You're sad because this is the last set of notes for this year?
Yeah, I'm just so depressed that we're not gonna have more packets of notes.
Oh, I'll get you more.
Oh.
Hey, if that's what you want.
No,
I got some leftover unit 2s
no,
if you want some of those.
You know, now that I really think about it, I'm not really that.
You don't want to go that far?
Yeah, I don't even like. I'm not even that sad about it.
Oh, okay. Anyway, all right. So parts. So to do this, it's going to be 0 times period plus my phase shift. Does this one have a phase shift? No, it doesn't, right? Because right here is just 1/2 x. There's nothing else adding or subtracting to that. So it's going to be 0 times period, which is 4 pi, which gives me 0, right? Next one is 1/4 times 4 pi is going to give me 1/4 of 4? Go ahead. 1, right? Yes. 1/4 of 4 is 1. So that's going to be 1 pi half times 4 pi, 2 pi, 3/4 times 4 pi, 3 pi, and 1 times 4 pi. And now we're going to plug these in. Right?
Yes.
Yes.
Good.
Yes. So I'm starting over here. Wow, that is a horrible, horrible line. That's just as bad. So starting at 0, ending at 4 pi. My amplitude is 2, so I know it's going to go up, right?
Yeah.
And down. All right. So it was, let's see. It was 2, what's it again? Cosine 1/2 x. So 2 cosine 1/2 times 0. Now, if you got your unit circle out, hopefully this will be helpful. So 1/2 times 0 is
0.
0. What is cosine at 0?
Like 0. 1.
It's 1.
Yeah.
Okay, because cosine is all the way to the right, isn't it?
Yeah.
So it's going to be 1 times 2.
2.
2. 2 cosine of 1/2 times pi. Yes.
Okay, so because this is why did you change it to cosine?
Because we're going to do the secant at the very end. So everything else is going to be the same, and then we are going to graph it. So we do all this, and then to graph it, we turn it into secant. Because you're going to have a lot that are asymptotes here, and whenever you see an asymptote, it's going to be undefined. And I'll show you where that happens. All right, so 1/2 times pi is pi over 2. What is cosine at pi over 2? 0. 0 times 2?
It's still 0.
There we go.
Yeah.
2 cosine of 1/2 times 2 pi. Half times 2 pi? 1 pi, right? 1 pi. What's cosine of 1 pi? -1. -1 times 2? -2. One half times 3 pi.
3 pi over 2.
3 pi over 2. 3 pi over 2. Cosine at 3 pi over 2.
-1.
It's straight down on the unit circle, so it's -1. No, it's not. It's 0. Straight down. Cosine is the x value.
Oh, yeah. I'll leave that.
I know. See?
Yeah.
Checking right there. So that's going to be 0 times 2?
0.
0. 2 cosine of 1/2 4 pi
2.
2 pi. Okay, what is cosine at 2 pi?
1.
1 times 2. Alright, so I'm going to do this in blue so we can see where this is. Now, starting off at 0, it's up at 2. At pi 0, 2 is -2. 3 pi is 0, 4 pi is 2. So this is the cosine function. Right? Say yes.
Yes.
Now, we're going to do the secant. So 2 secant of 1/2 x. So what I said was at the maximum, it goes where? It's going up, right?
Mm-hmm.
It's going to go up. So I will show you this now. If we plug these in, you will see what we end up getting. So right here, at pi, because that's going to be my 0, I'll show you this. So 2 secant 1/2 pi. That's pi over 2, right? Say yes. Okay, cosine at pi over 2 is 0. Okay, I could write 0 as a whole number, right?
Yes.
I could write it as a whole number and I could write it as a fraction. So 0 as a fraction would be 0 over 1. As a fraction, 0 over 1, right? But secant is the reciprocal of that. So I take 0 over 1, and what do? Flip it over. Then it becomes 1 over 0, isn't it? 1 over 0. Can I divide by 0?
Nope.
No. I cannot divide by 0. That is undefined there. And so if you want to plug in the calculator, you could actually see what happens there. You'll get it. It says undefined. So right there, we're going to get an asymptote. Make sense? Lass, you good? Abraham? Maybe? Are you questioning this? No? If you're having trouble with the math, plug it in the calculator. Plug this in the calculator. Plug in 2 secant 1/2 times pi. Okay, if you're having trouble with that, just plug that part in. Make sure your calculator is in radians. Now, it's going to happen again over here at 3 pi. It's going to happen again at 3 pi. At 3 pi, I'm going to get another one where it's going to be an asymptote here. Okay, it's going to be undefined right there. And like I said, on the maximums, those flip up. And on the minimums, those flip down. So if I were to take, like right here in the middle, in between pi and 3 pi, that is a minimum. That's the lowest point, right? So I basically take this blue line in between the asymptotes and flip it down. So it's going to go like this, but it's heading towards the asymptote. So that's what I mean about this flipping. So my function in red is the actual secant function. So that's the bottom part. So now the upper part, since I started right here at 0, and I'm reading from left to right, it's approaching this asymptote. So this is going to be flipped up right there. And in between 3 pi and 4 pi, same thing, it's approaching this asymptote right there. Does that make sense? It is.
At first I was like, in and out like 5.
So we got the cosine part, right? All we have to do is the difference is for the graph on the secant.
It's like the asymptotes. And then,
Questions, concerns, complaints?
I think you can.
Are we good? Okay, let me do one more, then we'll pause and I'll have you guys try some of these. All right, so they did it over 2 periods. I only did it from 1. All right, this one here. This one has a phase shift too.
This was crazy.
So going through my steps. Step 1 is my amplitude, right? My amplitude here is 3 over 2. Step 2 is period. Period is always 2 pi over b, right? And again, we're going to pretend like this one right here, y equals 3 over 2. So that's going to be a sine of x minus pi over 2. Because I'm going to treat it like it's a sine, because I do everything else the same. Getting to the point of graphing it, everything else is the same. So my b value is 1, right? So it's going to be just 2 pi for the period. And 3 is my parts. 0 times the period, which is 2 pi. And add my phase shift. So what's my phase shift going to be here, though?
Yeah, you're gonna add a half, or you're gonna add pi over 2.
I'm adding pi over 2. Remember, it's always going to be the opposite sign right here. So it's going to be plus pi over 2. Quarter times 2 pi. 1/2 times 2 pi. 3/4 times 2 pi. And 1 times 2 pi. What the hell? I'm tripping. Alright, I know you guys are trying to do the math right now, because that's what good students do. Try to do the math. Yes, I put some fractions up there for you. This first one should be pretty easy. I get. What's 0 times 2 pi? 0 plus pi over 2? pi over 2. Next one is going to be, let's see, quarter times pi over 2. That's pi over 2 plus pi over 2 is 1 pi. Do you guys get 1 pi on that one?
Yeah.
Okay. Next one is going to be that 3 pi over 2. Next one's going to be 4 pi over 2, which is 2 pi. Next one is going to be 5 pi over 2.
Yeah, that's what I thought.
Did you at least write it down?
Yeah, that's one.
Okay.
This is blocked by my pen, so yeah.
Questions, concerns, complaints so far?
You have coffee?
She made a pie.
Oh, Daddy wants lunches.
What are you doing? What are you doing? Did you already get the coffee? You got to get first cup, right? Since you made it.
It's not that much.
Oh, is it still going?
No.
All right. So I'm going to the next part, which is going to be my graph. Positive pi over 2 ends at 5 pi over 2.
I'm gonna go clean this mudroom in the sink.
All right, sure. I get pi, 3 pi over 2, and 2 pi. My amplitude was 3/2, right? And my function was y equals 3 over 2 sine of x minus pi over 2. So I'm going to start plugging in my values. So y equals, I'm not going to do the y equals. Pi over 2 minus pi over 2. All right, pi over 2 minus pi over 2 gives me 0. Now, unit circle, sine at 0 is what's sine at 0?
0.
It is 0. At 0, all the way to the right. Sine is 0 times 3 over 2, 0. 3 over 2 sine of pi minus pi over 2. So you have a whole pi, and you subtract half of a pi. How much pi do you have?
Not very much. I don't look at you like that, right? Can you ask that again? I like.
You have a whole pi,
Uh-huh.
and you subtract half a
Oh,
pi.
you have half a pie, yeah.
It's positive 1/2 pi, right?
Yeah.
Good. So what is sine at 1/2 pi? Or pi over 2?
Sine 1.
1 times 3 over 2?
It's 3 over 2. What glue did you use for this?
The one that has donuts in it.
Okay. Yeah, Denny's just itching to get his hands on the vanilla one.
Yeah. For like 6. That's sugar in it.
All right, so 3 pi over 2, 3/2 of a pi,
Uh-huh.
you subtract 1/2 of a
I
pi,
have 1/2 of that. Or no, 1 a pie. You're
1
subtracting
pi
half
left,
and
right?
one
1
left,
pi.
yeah.
All right, so What is sine at pi?
0.
0 times 3 over 2.
0.
All right, we have 2 whole pies. I subtract half a pi. How much pi is left? 3 pi over 2. So 3 pi over 2. What is sine at 3 pi over 2? Negative 1 times 3 over 2.
Negative 3 over 2.
There you go. And let me see. So 3 over 2 sine of 5 pi over 2 minus pi over 2. Five half of a pi. 5 halves of a pi.
You need to subtract 1/2 of the pie. You have 2 pies left.
2 pies left.
Yes.
What is sine at 2 pies?
0.
0 times 3 over 2.
Still 0.
Still 0. All right, so I'm going to do this one in blue. And this is the sine function. So starting at pi over 2, it was 0. At pi, it was positive 3 over 2. 3 pi over 2 is 0. At 2 pi was negative 3 over 2. And at 5 pi over 2 was 0. So my graph of the sine wave is right here.
Yes.
And now let's do the cosecant. All right. So, if you want to feel more comfortable about this, you can plug in each one. But I told you, when it's at 0, on the x-axis, whatever your baseline is of where it is going to wrap around, it's going to end up having an asymptote. So if I plug in 0 right here, so if I plug in this one right here, which is pi over 2. So pi over 2 cosecant is the reciprocal of sine. Sine at 0 is 0 divided by 1. And the reciprocal, the cosecant of that, of 0 over 1 is 1 over 0, which is undefined. So right here, we are going to get undefined. So same thing's going to happen right here at 3 pi over 2. And at 5 pi over 2. And just like I said, the minimum and maximum, they flip. They go upside down. So right here at the maximum, that's going to flip up, go this way. And the minimum is going to flip down right there.
We're good. Never mind.
Just like that. Angel, you still awake? All right. This is kind of easy.
Yeah.
All right. So let's go ahead and get started. So I'm gonna pause the recording here, and then get us started on the homework. Alrighty, you people. Let's go ahead and finish up these notes. Now we're gonna identify. We're going to determine a graph, determine the function by the graph. So first thing I'm going to do is pay attention. I'm going to start by drawing in the function that I would have in the first place. So starting at this right here sine, if you look at the unit circle, sine at 0 is what value? Say 0. 0. So that's going to be the easy one to identify. So you always start by looking at 0. Sine at 0 is 0. Cosine is 1, but if there's an amplitude, it would be 1 times whatever that amplitude. So a cosine function would be whatever the amplitude is. So this one right here looks like it's going to be a sine function because at 0, it's 0, right? So from here, and I need to look. So starting from beginning to end, the wave goes 4 pi, right? Say yes.
Yes.
Okay. So to do this, it's going to look like this. So my wave 2 pi over b is equal to 4 pi. My period is always 2 pi over b, right? So I'm setting this up because I want to try and figure out what the b value is. So I take the period where it comes out to be and I use the formula. So I'm going to multiply by b on both sides. So if I multiply by b and then divide by 4 pi, because I'll have b over here all by itself, right?
And then you'll have whatever that ends up being.
Yes, and the b's cancel it out over here, right? So now it's 2 pi over 4 pi, which gives me, the pi's cancel, 1/2.
Just 1/2, yeah.
2 over 4 gives me 1/2. And so that's why I was able to actually get this here. So my b, and since we said this starts off as a sine, and it's the reciprocal of sine, so that's going to give me cosecant. So it's CSC of my b value, which is 1/2 x. So that's where we get those from.
And there's no phase shift, so you don't have to do
Yeah. Okay, so listen. Let's start with sine. Sine at 0 is how much?
Sine 0 is
0.
Yeah.
Okay, good. So a phase shift would mean shifting everything. Okay? So if I do a phase shift on cosine,
Oh, so yeah, it's so like
if I shift the cosine, which at 0 is 90, or is 0 is 1, I'm sorry, and I shift it pi over 2 or 90 degrees, right? So I move it over. So instead of starting at 0, I would start at pi over 2. Cosine at pi over 2 is 0. They are equal. They're just one phase shift of pi over 2 apart. So it's really hard to identify these if you have a phase shift also. So just basic functions like this where you have your sine and cosine.
no phase shift.
Yes, and try to ignore the phase shift if you can.
But
Okay.
if there is one, you're gonna have this problem a little bit. Like,
Yeah, you're going to have to like plug and play. So you have a calculator too.
Yeah.
That will actually help you with this.
because you can graph on the calculator.
Yes, you can. So you can graph the calculator to make sure that it fits correctly. And so you could just plug in and try different things. So that's right here. So if I have this one here, let's see. So if I start here, right? And
So you have a phase shift of like plus pi over 2, right? Because it starts at 0, but it's like the asymptote is at negative pi over 2. So like, and is this a sine
it's not
function?
not a phase shift.
Not a phase shift.
Not a phase shift. I said start at 0, right? Okay. So at 0, cosine would start with the amplitude, right? Or the 1. Okay. But this one right here, what does it have? What's different about this? Is it wrapping around the x-axis?
No, it's a wrapping above 1 or around 1, I guess.
On positive 1, right? So that means that the whole thing is moved up, isn't it? So it has a plus 1. It has a vertical shift. The vertical shift is outside the sine or cosine, whatever. So I'm going to start with my function being So it's 1 plus, now, if you start at 0, right?
Cosine.
That's going to be a cosine, right? So right here, if it was starting at 1 right here, this would be a sine, right? So this would be a cosine. And it's going from here over to here, which is going to be pi, 2 pi. So if I go to right here, that would be 2 pi, right? So this thing just looks like this to confuse you because it would be a phase shift apart. So this would be a cosine. If I go from here to here, it's cosine, down, all the way up and around. So is that going to be a different period? Say no. No, because cosine would start up here and it would end up here, right?
Yeah.
One whole wave would start at the top and end at the top. So right here, my period is not going to be different. It's going to be 2 pi. So this would be cosine, and the reciprocal cosine is secant of x.
Yeah, that's it.
That's it. Because you always got to try and read this according to 0. So I could actually say it's this right here. This would be exactly the same as saying 1 plus cosecant, because it's a phase shift apart. So this one, if it's starting over here, it's x, and that would be plus pi over 2.
That's what I was talking about.
So they're both the same. These would be exactly the same. If you were to graph these on your calculator in radian, they're going to be on top of each other. They're just a phase shift of pi over 2 apart. And get to know your calculator. You know, the graphing part. Hint, on this test, you could use your calculator, and it's almost all, you can plug it in to actually get the right answer. All right? Okay, make sure you guys like, share, and subscribe. Hit that notification button, and support my channel by using promo code
Early bird.
EARLYBIRD. Yes, I know it's early something. And 10% off.